Hello. All right. Let's see. Is this working? Looks like it's working. Put this over here. Why do I hear my own voice? It's because I'm listening to Twitch. Let's mute that. There we go. That's better. All right. Let's see. What are we doing today? I'm going to try to figure out if I can get this live stream set up here, get my screen shared. See, share screen. Should do that. Do that. And share. Okay. Is that working? I guess that's working. Okay, there we go. Let's close a couple things here. Make sure we have a nice one screen here. Let's got the Exercism tab up. Let me get a terminal window out here. Let's make this a little bit bigger. I'm just getting started here. I'm kind of a streaming noob, so if this doesn't work well, it's totally my fault. Let's see. How can I see the chat? There we go. Stream chat. Welcome to the chat room. Mute that again so I don't hear myself talking. All right, so today we're going to just solve one of the exercism challenges for the mechanical march. Um, so I'm logged into exercism here. I'm on the check out the mechanical march 12 and 23 page, and it can kind of show us what's going on. There's a couple languages that I'm somewhat familiar with in mechanical march. I've done a fair amount of Go in my past life. I don't do a lot of programming anymore, but other than just kind of for fun. Um, but the Go track on Exercism was a big part of how I learned Go when I first started using it quite a while ago. Um, and the track is really wonderful. Like it's well curated. The exercises make sense. There's lots of hand holding through how you work on the different projects in Go. If you're looking to learn Go, I highly recommend checking out the Go track because it's really well done. We're gonna kind of jump right in. Um, on the Go track here, I'm gonna click and we can see all the exercises here, some that I've done, um, and then we're going to find the one that I wanted to do today, which is vehicle purchase. It's a learning exercise. Let's check it out. So I have the Go the Go tooling set up on my computer, so I'll probably use that to do the exercise. But I wanted to just present really quickly the interface. I really like the editor that they have embedded in the website. If you don't have the language tooling set up on your machine, it's really nice to just jump right in. You can just click Start an Editor, and what's going on with my internet? And you can start working on it in any language that they support. So, um, I was playing a little bit with Elixir and Erlang in functional February, and I didn't have all the tool chain installed on my machine, so I didn't have a setup on my machine, so I couldn't really. I didn't want to take the time to work on it, so I just hopped right into the editor right here, and I just started implementing directly right here, which is really nice to do. especially if you don't have all the tooling set up on your machine. Um, in the case of Go, I do have all the tooling set up on my machine, and I'm comfortable in my tooling, so I'm going to do that. Let me zoom in a little bit here. It looks a little bit small on the stream. How do I zoom in here? Hello. It's a little better. I don't know why, but this is very laggy here. All right. So let me make this bigger too. How do I make it bigger? There we go. You can see now. Sorry, just arranging some windows a little bit here. Bring up a TMUX session. I think I have an Exercism directory already. There's some stuff in there you can see. Go to the Go track. Last one I worked on was Party Robots. We already did that one. So now we're going to look at vehicle purchase. And so for vehicle purchase, there's a little hint here. It says if you want to work on if you want to work on it locally with your CLI, you just copy paste this little command here, exercism download, the name of the exercise. So we're going to just do that. Exercism download -- exercise vehicle purchase track equals go. So then it tells me it downloaded. Downloaded should be in this directory now. Vehicle purchase right there. Cool. I have all these nice files here, which kind of are duplicating everything that's written here on the exercise page. So I'm just going to read through the exercise really quick and go over look at what we need to do, try to figure out where to start. So basically, this is going to be helping us learn more about conditionals, if statements, for example, and comparisons in Go. So two concepts that we'll be learning in this particular problem. So it says we're going to write some code to help prepare to buy a vehicle. We have three tasks. We have to determine if we need a license. We need to choose between two vehicles, and we need to estimate the acceptable price for a used vehicle. So first step here, it says determine if you will need a driver's license. Some vehicle kinds require a driver's license to operate them. Assume only the kinds car and truck require a license. Everything else can be operated without a license. So cool, right off the bat, sounds like we're going to need an if statement to check if the type is a car or if the type is a truck. We want to say yes, you need a license. Anything else that goes into that function will just be no. So yeah, here it goes. It says implement the needs license kind function that takes the kind of vehicle and returns a boolean indicating whether you need a license for that kind of vehicle. They give us some nice examples here. So if I call needs license with a car, it's going to return true. If I call it with a bike, it's going to return false. If I call it with a truck, it's going to return true. Cool. So that's kind of step one. I'm going to I'm going to finish reading the rest of the problem just so I have a full idea of what the whole ask is before I go back and start implementing any of these things. So the second uh, step is to choose between two potential vehicles to buy. So we evaluate our options and we narrow it down to two, and then we're going to implement a function that is called choose vehicle that takes the two vehicles arguments and returns a decision that includes the option that comes first in lexicographical order. Lexicographical, I guess that means just what is closer on the alphabet. I think lexicographical has to do with the alphabet. I'm not totally sure. So vehicle, choose vehicle. We have an example here. Between the Wuling Hongguang and the Toyota Corolla, it's going to return Toyota Corolla. And between the Volkswagen Beetle and the Volkswagen Golf, it's going to return Volkswagen Beetle. So yeah, because it's doing, I guess, lexicographical, it's doing here W is later than T in the alphabet, so T is going to come first. It's going to return the Toyota, and here uh, G is before, no, B is before G, sorry, so it's going to return Beetle. Uh, so that makes sense. There's probably, maybe there's a function that helps us do that in Go. I'm not sure. Calculate an estimation for the price of a used vehicle is the third step. So now that we've made a decision, we want to make sure we get a fair price at the dealership. Okay. So we're going to implement the calculate resale price, and it's going to take an original price and the age, and then I guess that's the age of the car and the original price of the car. And you're going to use if, and else, takes the original price and the age of the vehicle as arguments and returns the estimated price in the dealership. So yes, it's gonna basically tell us how much we can get for the trade-in value, I guess, for our used car. Um, and this says note return value is a float 64. Okay, cool. So let's go back up to number one, and let's see what we have over here in the stuff that we just downloaded. So we have the README, which is basically should be similar to what we just read. Here, actually, there's a little bit more information here about comparison operators, um, if statements. So this has a little, I'm sure this is somewhere on the exercise. Probably when I click start exercise here, it's probably going to give me some of this information. Yeah, here we go. So this is what I'm seeing in the README file is right here in the instructions. So it's giving me lots of nice tips on the things I'm going to have to use to figure out this problem. So if statements, conditionals, uh, etc. And here I have the tasks nicely laid out, and I have hints if I need some hints, I can get those hints, which is really nice. So we'll start with task number one. We're just going to jump into task number one here. It says determine if you need a driver's license. Like I said before, this looks like a simple if car or truck, return true, else return false. So um, we'll jump into the editor over here, and we should have a stub already for the um, for the implementation, and it's here. It's called vehiclepurchase.go, and the test file is called vehiclepurchase.test.go. Sorry, vehiclepurchase.test.go. So let's open up the purchase.go, and let's go ahead and open the test as well while we're here. So here we have the same thing that we have in the UI in the editor, right? We have the same exact kind of stub file here, and we can start implementing the functional logic here. So the first step is just going to implement this function here. We need to get rid of this panic. This is just killing the program whenever it comes in here. So if I run the tests right now, go to the Exercism directory, and in here in the vehicle purchase folder, I run go test. I should get a bunch of failures. Yeah, I see there's some panics. Panic needs license not implemented. So that's what we see right here. Needs license not implemented. So right now all the tests are failing because I haven't done any work. So we're going to start here just by starting to work. So we have a kind. We're given a string which is a kind here, and we need to check to see if it's a truck or a car. So we're just going to do when I'm doing these, I like to start kind of very naive, and I just kind of solve the problem the easiest way that I can. Um, there's probably better ways to start solving the problem, but like I just kind of do the fastest, simplest approach that I can think of. So super simple here. We're going to do if kind equals truck. Uh, and it's been a while since I've done any Go programming, so I'm going to get a lot of errors here, but that's fine. If kind equals truck, let's say return true. So if kind equals truck, return true. Let's get rid of this panic. And I've kind of messed up already because like I've forgotten all the syntax of Go here. My editor is complaining loudly at me that I need a opening bracket, and it didn't find one. Um, uh, so I think I need to do for if statement. I think I need to do what? Let's look at the exercism here. It tells me really quickly where to go. Here we go. So here we have some examples of if statements here. So I can look at these to get a refresher on, oh yeah, how does an if statement work in Go? It works like this. Okay. So this is what I need right here. If value equals value, return yes. Perfect. So if, let's just look at that, make sure we're doing it right. If value equals truck, so I'm missing these opening bracket, close bracket here. Return true. What is this telling me? Missing return. Okay, we're just going to put return false here for now. So right now, all we do is if the kind is a truck, we return true. Otherwise, we return false. So that should get one of the tests passing. Well, let's see. Does it? Needs license not implemented. Oh no, that's the last time we ran it. It's hard to see with this giant font what's going on here. Let me clear the screen. Dun, dun, dun. I just saw it. Go test. There we go. Fail, 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 fail. So I guess that didn't. Okay, needs license car. Okay, if kind equals truck, return true. Let's do car really quick. If kind equals car, we do the same thing, return true. Otherwise, we're going to return false. Does that help? Go test choose vehicle. Okay. So choose vehicle is now failing. Okay, so it's not showing us what's passing. I forgot how this worked. Like I said, it's been a while since I've done any programming in Go. So now we have some test passing because I don't see that. I don't see those fails anymore. I can look and see. I can look at the tests really quick just to see what they're doing. Needs a license for a car, so car should return true. Needs a license for a truck, truck should return true. And then it's going to test bike, stroller, and e-scooter, and those should all return false. And that's what is going on in our code. If kind is a truck, return true. If kind is a car, return true. Otherwise, return false. So we have that one. Step one is done. We've implemented now the needs license function. Whenever the code asks if we need a license to drive this kind of vehicle, it's going to say yes or no based on that function that we just put in here. All right, so let's look at part two. Where's part two? The nice thing about using the editor here is it actually shows you which tests fail and which tests pass. And here it shows one test failed, but I think it also lists the test that passed when you actually pass tests as well. Whereas in Go, it's just silent if you pass the tests. I think that's a Unix philosophy. If nothing went wrong, then don't say anything. Let's hop back to the instructions. Let's look at the next one. Next task is, I don't know why everything is lagging really a lot on my local machine right now. Choose between two potential vehicles to buy. Cool. So let's look at that. So we get two vehicles, option one and option two, and we return a decision that includes the option that comes first in lexicographical order. So let's look at our stub here. We have option one, option two, which are strings. I'm just gonna take a guess here that if we compare two strings, if option one, so we want to return the whichever one is closer to like A, whichever one comes first in the alphabet. Um, so I think if we just compare two strings, it'll return. If I say option one is greater than option two, my brackets, then we can return option one. We want, because I think greater when you're comparing strings means in alphabetical order which one comes first. I think you can do that with strings in Go. We're going to try and find out. So if option one is greater than option two, return option one. If option two is greater than option one, return option two. And like I said, I'm looking for the easiest kind of most naive solution right now. So I just want to pass the tests. And once I get the test passing, then I can go back and optimize and say like, well, I probably don't need two if statements here. There's probably a way to make this a single if statement or to do some fancy conditional here where I can, just return the right response with one in one shot instead of having to do multiple ifs. But I'm not going to worry about that too much. Why is this complaining? It says missing a return. Okay, so I don't have a bare return here, so Go doesn't like that. So I have a return in this conditional, and I have a return in this conditional, but I don't have just a return here. Um, I don't know what to return if neither of those are true. What if they're the same? It always recommends the vehicle that comes first in lexicographical order. Interesting. So I don't know what to do. It's not specifying what to do if they're equal. If nothing, um, if they're the same, I don't know what we return. It's not specifying. So maybe it doesn't test that. Let's just say for now return option one. So if they're the same, yeah, if they're the same, it doesn't matter which one we return because they're the same. So my bad. That's yeah, they don't have to specify that. So let's try that again. Go test here. Let's see what we've got. Let me close this because this is hard to read. All right, choose vehicle, choose Bugatti over Ford, choose Bugatti Veyron, Ford Pinto, want Bugatti. Bugatti. Okay, so Bugatti is clearly the better choice. Uh, so I picked Ford Pinto, but I should have picked Bugatti. So maybe I'm doing the comparison backwards. Here we have Ford Pinto Bugatti. Yeah, I should have picked Bugatti. And here we have Cherry EQ Kia. Kia want Cherry EQ. So I picked the Kia, but I want the Cherry. So I think I just inverted the conditionals there. Um, so let's switch this around. If option one is less than option two, and if option two is greater is less than less than option one, then that should fix the problem. So um, I just turned around the way that the lexicographical order when you're comparing two strings, which one's greater and which one's less than. Um, so let's see, that should fix that test. I can't see anything here. Choose vehicle Bugatti, Ford Pinto, want Bugatti is clearly the better choice. I'm still failing here. What's going on? Oh, right. So I'm just returning Bugatti. I'm just returning the name that they passed in, but they actually want. That's not actually what they want. Um, they want the name of the vehicle followed by is clearly the better choice with a period. So I'm missing that part um, of the return. Right now, I'm only returning the name. I'm just returning Toyota Corolla, and the tests don't like that. It's telling me in the tests here fail. Uh, it's getting Cherry EQ. This is what I'm returning, but what it wants is Cherry EQ is clearly the better choice. So I need to add a string at the end when I'm returning. Instead of returning just option one or option two, I should be returning uh, option one plus a string that says is clearly the better choice. So um, let's say what we're going to do here. I know I said I usually do the naive and simplest approach, but we're just going to, since this is going to be repetitive, instead of returning here, I'm going to say choice equals option one. And down here, I'm going to say choice equals option two. And actually, that's going to just be an option like this. And up here, we're going to say var choice is a string. I think that's how you do that. Maybe not. Choice declared but not used. Okay, choice equals option one, choice equals option two. So because of the way scoping works in Go, since choice is used down here, but it's defined out here outside of this if statement, um, Go is complaining because I have defined this variable choice, but I haven't used it anywhere because it doesn't see this usage in here because this is conditional usage. But down here, as soon as I say return choice, I just said like that, return choice, it's going to stop complaining about that because now I'm using choice. But I don't want to just return choice. I want to return choice plus the string. And I think I can maybe just do, I'm not sure this is going to work. Return choice plus is clearly the better choice. I'm not sure if that's going to work or if it's going to give me is clearly, let me just make sure that I'm writing the right string here, is clearly the better choice, period. Return choice is clearly the better choice, yes. So let's try that and see what happens. Let's make this big. There we go, big. There we go. So save, run our tests. Cool. So that looks like that. That fixed that. So that function's working now. So choose vehicle is implemented and needs license is implemented. So we have 2 parts done. We have a couple tests left to pass here. And so let's go back and look at step 3. So we have 1 and 2 implemented. Task 3 is calculate an estimation for the price of a used vehicle. Okay, click on that to open it up. Now that you've made a decision, you want to make sure you get a fair price at the dealership. Interested in buying a used vehicle? The price depends on how old the vehicle is. For a rough estimate, assume the vehicle is less than 3 years old. It costs 80% of the original price. If it's at least 10 years old, it costs 50%, and it's at least 3 years old or less than 10 years, it costs 70%. Okay, so this is going to be like a bunch of if else statements, I think. So calculate resale price, if else, if and else. Dun, dun, dun. Okay, so let's look here at what we have to do. So if the vehicle is less than 3 years old, if the vehicle is at least 10 years old, and if the vehicle is at least 3 years old but less than 10 years old. Okay. At least 3 years old but less than 10 years old. At least 10 years old and less than 3 years old. Okay, so less than 3 years old seems like, let's do that one first because that looks like the easiest conditional to worry about. So we're going to go down here to our last function that is not implemented, and we're going to get rid of the panic. What doesn't it like there? Missing return, right, because we got rid of the return. So we're going to start with if age less than 3, right? If it's less than 3 years old. If age is less than 3, then it costs 80% of the original price it had when it was brand new. So if age is less than 3, we're going to return original price 80% when it was brand new. Okay, so original price, return original price minus original price times what does it say? 80%? 80%. 80%. So let's see. Times, I don't know if this is going to work. I don't think so. Times 0.80. So we're going to subtract 80% of the original price from the original price and return that. Does that work? Missing return. Okay. Huh. I'm surprised. I was thought it would complain about my just throwing a multiplication right in here like this, but I guess not. So if age is less than 3, return original price. Let's just see here. Let's just return 0.0 here, just to quiet the linter. So if age is less than 3, does that work? Go test. How many tests do we have here? Fail. Want 32,000, got 8,000. 2, what does 2 here want? 2 is age, right? So for age 2, 40,000 equals 8. For some reason, I'm returning 8,000. So I'm probably doing something wrong with my math here. I'm not the best math person in the world. let's see, original price times 0.8. That should give me 80% of the original price, I think. Let's see, 100.8 is 80. That's 80%, yes. And then I'm subtracting that from the original price. Okay, something's off with my math there. We'll fix that in a little bit in a little while. Let's get the rest of the conditionals set up for now. So that's one conditional there. If age is less than 30, or age is less than 3. The next one is assume if the vehicle is less than 3 years old, it costs 80% of the original price it had when it was brand new. It costs 80% of the original price. Oh, okay. No, that's right. Isn't that right? I'll figure out the math after. I'm making a mistake and confusing myself. So let's get the conditionals and then we'll go back and we'll do the simple math that I can't do afterwards. This is why I became a programmer, because I didn't have to do the math. I would let the computer do the math. All right. If it's at least 10 years old, it costs 50%. And if it's at least 3 years old but less than 10 years old, it costs 70%. So if it's at least 10 years old, so if age is greater than 10, greater than equal to 10, it's 50% of the price. So if age greater than equal to 10, so if it's 10 or older, we're going to return 50% of the price. So I'm just going to do my same bad math here. Original price minus original price times 50. And I spelled original wrong. Thank you, Linter. Original price minus original price times 50. And then the last one is, and actually, yes, so if age is, what is it, greater than 3 but less than 10, 70% of the original price. So if age is greater than 3 and I think greater than equal, actually, right? If it is at least 3 years old, yeah, so greater than equal to 3, and age is less than 10 years, but and age is less than 10 years. We're going to have a different case here where we return something else. Return, and we're going to say what? Return 70% of the original price. So original price minus original price times 70%. Okay, otherwise, okay, so 1001 should return 800, 1005 should return 700, 1015 should return 500. So let's see. Test, they're going to all still be failing because my math is wrong everywhere here. Okay, so let's see, what am I doing wrong here? So let's just trace through what this is doing. So if age is less than 3, so we're doing this first case here. So if we pass in 1001, we're taking, let's just do this, 1000 minus 1000 times 0.8, which gives us what? So original price is 1000 times 0.8 is 80%. That's 800. So 1000 minus 800 is 200. So that should be 200. No. Okay, so what am I doing wrong here? Because it wants 800. Okay, I'm discounting I'm saying, okay, I'm saying that this, I'm giving an 80% discount, but that's not the case. I'm actually, oh, okay, I see what I'm doing wrong. I'm returning, I'm taking 80% off the original price, but really it should only be 20% because the car's value, it's worth 80% of what it was worth before. It's not worth 20% of what it was worth before. So I'm solving the wrong thing here. So instead of taking off 80%, I want to be taking off 20%. So let's see. Uh, so if I return just 80% of the original price, let's see. Return. Let's try this. Return 80%. Let's just return original price. Let's just return 80% of the original price. Does that work? Yeah, that works. Okay, so I was discounting it instead of taking a percentage of the original price. So I was doing a step too many, because I was subtracting the percentage from the original price, which we don't want to be doing. We just want to be returning the percentage of the original price that the car is now worth. So in the first case, it's 80%. In the second case, it's 50%, and in the third case, it's 70%. So yeah, overthinking. My bad. So that should work now. We've got the age is less than 3, return original price. Age is greater than 10, return 50%, 70% if it's between 3 and 10. Cool. So that all passed. So that's um, all three of these cases here implemented. Um, so now we can submit this exercise. And once we submit it, because we have the test passing, we can think about, can we make it better? Should we make it better? What can we do? So let me just save this. And to submit the exercise, I think it is, there's an Exercism command line tool. I think it's just submit. And I think as long as we're in the directory that we care about, it's going to automatically know what to submit. Your solution has been submitted successfully. View it at vehicle purchase. So we should be able to see it here. Vehicle purchase. We have an iteration here. Cool. And like I said earlier, here it shows you when all the tests pass, which is really nice if you're using the UI because you can see, oh, cool, I got this one working, I got that one working, I got that one working, and then you can see what's not working still. And it's helpful for proceeding through these things a little bit more than just the command line um, telling you that there's not telling you when you've got it right. Thanks, RP1 MUS. I was yeah, my math skills are not the best. Like I said, I got that um, figured out. So um, cool. So that's submitted now. The nice thing about when you submit your problem is you get to look and see what other people did to solve the same problem, which is really nice if you're learning a new language or even if you're kind of new to a language because you can see how people who maybe are better than you solve the same problem. So like here we can look and see like uh, and you almost always are going to see a different approach, right? Somebody's going to have done it slightly differently than you did it. So here we can see like this guy uh, Andre, how he solved the problem, and we can see like, oh yeah, okay, cool. So here he just did an inline return, kind equals car or kind equals truck. So uh, nice, it's one line, it's super simple. And choose vehicle is much more streamlined than the one that I did with like a bunch of different ifs. Here, so he calculated a percentage, and then he handled the two cases, the two kind of exit cases, and then the fall through is just the original price times 50%. So that's really a nice kind of um, uh, compact, nice solution. I like it. 25 lines of code. Um, I don't know how long mine was. Let's take a look. So yeah, 45. So he's about half. He did about half the lines of code that I did, which is always nice. If you can do it a little bit smaller and still nicely legible. So um, once you finish your exercise, you can go and you can see other people's solutions, which is great. And you can also ask for mentoring. So you can say, hey, I'd like some mentoring on my solution. I'm not sure it's the greatest. I'm new to this. I don't know what if I'm doing it right. When I first started playing with exorcism, the mentoring was like really the thing that drew me to it, because it's like you get people who know the language more than you, who are mentoring you and who are saying, if you want this to be more idiomatic, you should probably do it like this. Like Go. Every language is a little bit different, and people who are good at those languages have different kind of um, ways of doing things that are like culturally fit, culturally appropriate for that language. And in Go, for example, there's a lot of shorter variable names. Depending on how far away the variable is used from where it's defined. So you might use shorter variable names, or sometimes you don't do. You might not do like a long statement that has all of your conditionals in it. You might separate it out into different lines because of convention. But there's not a lot of. It's hard to learn that without kind of uh, doing it and getting that feedback. So the mentor aspect of exorcism was really like the cool thing that I was like, oh, that's really really awesome. And I actually started learning Go in tandem with exorcism. Um, it was right around at the same time I was learning Go. Exorcism was starting out, and the Go track was really well mentored, really well maintained, really well mentored. So that was really really cool to kind of have that growth, have kind of exorcism right there helping me as I was learning Go. So that was cool. And the nice thing too is you can participate as a mentor as well. Once you've kind of gotten the solutions a couple times, you can also help mentor other people, which was really cool. So let's see. What's next? So we have our iteration here. It's still marked as in progress because we haven't marked it as completed. I'm just going to mark it as completed because I'm happy enough with this solution. It's not perfect, but I'm happy with it. So let's see. How do I do that from here? I think I can continue. Let's see. Is there a little? No, maybe download. Well, since we started that command line, let's see if we can also finish here. Do we have a submit? No, we can't. We can't. We can't mark it as complete from the command line. Doesn't look like. So let's go back here. Vehicle purchase. I think in the overview maybe mark as complete here. So I can mark this problem as complete. I can share my solution with the community. I always like doing this because just as I get inspired from other people's solutions, somebody's going to look at my solution and be like, "Oh, cool, slightly different way of doing things. Let me try. Let me try doing that." So we've completed vehicle purchase. That says that we've unlocked 2 new exercises by completing this exercise. So I check off these 2 things here, and I've unlocked 2 new concepts: conditional switch and for loops, which are like, cool. Now that I know how to do if-else statements, they're going to give me a little something meatier to be like, hey, you can also use a conditional switch statement if you have too many if statements and it's starting to get confusing. You might want to use a case statement, for example. And they're going to introduce me to for loops, and I have 2 exercises here that I've unlocked, which are blackjack and birdwatcher. So it's nice because as you grow progressively in the learning path, you unlock other fun exercises that you can also do. So I'm going to click show me more concepts. We have about 15 minutes left. So I'm just going to go and start an exercise. We'll see how far we get. And I'll do this one in the UI just so that we can see all the nice stuff that the UI kind of offers while we're doing this. Um, oh yeah, this one could be a bit longer than the last one I did, so um, we'll start with it. And I'm unfortunately I have to stop at 10 to get back to work, but we'll go for as long as we can here. So let's start blackjack, um, and this is another exercise the on the syllabus path. So yeah, another thing to mention, like the languages that have syllabuses are really uh, are really nice. So I was doing in the functional February. I was like, oh, cool, functional February. I'm gonna do some Erlang. I've always heard about Erlang. It's really cool. Like, it does all these amazing things. I want to dive in and play with Erlang. So I jumped in. Um, Erlang is not one of the languages that has a syllabus on Exercism, so it was quite a bit more challenging to dive in. I think I did the Hello World. That was easy enough, but I think I got to the third exercise in Erlang, and I was like, okay, I do not know what I'm doing in Erlang at all. I need a little more hand holding. This is yeah, a little bit. The paradigm was a little bit outside of what I was comfortable with and used to. So I was like, okay, go back to the language selection page, and I saw, oh, cool. There's Elixir, which is also which has a syllabus. So I clicked on Elixir, and there's a lot more hand holding when you have the syllabus. So then it was like very much more like, okay, cool. This is easy to follow. I can ramp up a little bit quicker on this than I could on Erlang. So I was doing the Elixir track instead. I still did about 3 of the Erlang exercises, and maybe I'll go back to it someday. But for now, for functional February, Elixir was the way to go. Um, so these syllabus paths are really nice because they give you a whole kind of like learning journey, right? Like there's a graph of how you progress through a language, and you can't do stuff that you're not ready for. So like it's really well done, and I think Go in particular is a really strong language on Exercism because I think the early uh, the creators of Exorcism, I think they were Go programmers. I think they were doing a lot of Go at the time. Um, so let's just start this. We're not going to be able to finish it, but we can at least play in here for a little bit. So let's learn about conditionals by playing blackjack. Click on the exercise, and we will start it in the editor this time. We'll just read the instructions really quick. I think, yeah, we're just doing a blackjack game. I think most people know how to play blackjack. It's been a while since I played blackjack, so I'm probably going to have to look at these rules. Yes, okay, that's just telling us what the values are. Aces can take a value of 1 or 11, right? Stand, hit, split, automatically win. Okay, so we have a strategy here. We'll follow the strategy our friend Alex has been developing. If you have a pair, you must always split if you have a blackjack. So there's rules here for how to play the game, um, and calculating the value of the cards. So and implement this decision logic for the first turn. Okay, cool. So let's start that. We'll see how far we get. And here we go. So we got 2 functions, parse card and first turn. Tells us parse card is going to return an integer value of a card following the blackjack rule set, and first turn returns a decision for the first turn, given 2 cards, player and 1 card. Okay, so what we're going to do, what are we going to do? So like other languages, Go also provides a switch statement. And here it's going to show us just kind of how to use a switch statement. So a switch statement is basically like if you have a bunch of things like if this, that, if this other thing, instead of having to say if a million times, you can say case. So here we're switching on the operating system variable. So basically this is like saying if operating system equals Windows, do this. If operating system equals Linux, do this other thing. If operating system equals Mac, do this other thing. If no, if operating system is not in any of these things, then do the default thing, which might be, could be anything you want it to be. So that's they're giving us a nice hint here that we're probably going to use a switch statement here to parse the integer value of a card following the blackjack rule set, right? So we will um, we'll switch on the card, right? So we'll do switch guard because card is what we have being passed into the function. So we can switch on the card, and in here we're just going to put all of our cases. I don't remember a case. A card is a string, or I think they said it was like, let's see. Yes, yes, yes. So okay, so here's the card. So they're giving us the card um, in a string. So ace 1, 2, 3, 4, 5, 6, 7, and their values. So we're basically just going to do a big old case statement that um, says when card is. We're just gonna copy from this table here on the right over into our code. So case ace, and I don't remember the syntax for the case statement, so I got to look up here. So case 8, and then we do a little colon after our condition. So, and actually, this is already wrong because this needs to be a string because card is a string. So this needs to be a string. So in the case it's an ace, we're going to let's we can I think well let's just do instead of having let's see, do we want to have instead of having a return in every case, let's no, that's fine. Let's just do return. Case ace, so return 11. So when the card is an ace, we're going to return 11. So that in theory should work. Let's just say default here. Um, Actually, we don't need a default because we know what the every value has a defined every card has a defined value, so we don't need a default. Let's see, am I missing anything else here? Let's see, case ace, return 11. Uh, uh, yeah, I think that's right. Let's see, does this compile? I'm not sure. No, we still have the panic in here. Oh, but we passed the test. Parse card, parse ace. So we're parsing an ace now. So that's the like I was saying with the UI. It's nice because you can see which test passed and which ones are still failing. So we passed one test here. The ace condition is right. So cool. That was we're on the right track. I'm going to get rid of this panic because we don't want this panic here. Um, I think if I were doing this on the command line, I don't think it would have run the test there. I think it would have panicked and given me an error. But cool. Okay, so let's go back to our table here and let's just finish filling this out. So we got case 2, and we're going to return a 2, return 2. And like I said, um, I like to do the kind of the dumb solution first, and then if I'm feeling up to it, I can go back and make it better. Um, case 3. So there's going to be a lot of repetition here. It's going to be a big long case statement. That's just going like this. For every card, we're going to um, return an integer that's the string that the string is telling us the number of the card is. 3, 4, 5, return 5. Okay, 6, return. Usually when you're trying to write maintainable code, uh, as your function starts to get bigger and bigger, that'd be like a red flag. You'd be like, maybe I don't want my function to be quite so big. It's going to be hard to read and hard to understand. Um, in this particular case, because this is like um, a known kind of thing that we're implementing, maybe it's not such a big deal. But definitely, if I were looking at this doing a code review or something, I'd be like, okay, this is a little bit weird. Why do we have this giant big case statement here that's just doing something super simple? Maybe there's a better way to do that. So, but for right now, like I said, let's just do the simplest approach and get it working, and then we can improve after that. So where are we? 8, 9, return 9, return 9, case 10, 10. Okay, so we have a bunch of things that do 10. So we could do here uh, 10, Jack, Queen, King. So we could do case 10 or Jack, oops, or Queen or King. Return 10. So if it's a 10 or a Jack or a Queen or a King, return 10. So we don't have to do one line for each one of those. We can put those all in there. Um, did they say can take the value of 1 or okay, yeah, so they say right here, note commonly aces can take the value of 1 or 11, but for simplicity we'll assume that they can only take the value 11. So they're making our life simple. We don't have to add an additional condition that's like, well, sometimes ace is 1, sometimes it's 11. We're just going to always call it an 11. Okay, so oh, they do have a value for a default here. They have other. So if for some reason you get another card, you return a 0. So we can have a default. Default return 0. So if for some reason there's a card that doesn't belong in the deck, or there's a joker in the card, it doesn't count. It's going to be a 0. So let's run the test again now that we have parse card pretty fleshed out. I think that's all we need to do for parse card. So let's run the test and see how it went. Okay, syntax error. Okay, that's not good. Syntax error. Oh yeah, right. Because I'm missing. You notice a pattern here. I'm missing some colons. So thank you. If you're new to programming, uh, always make sure you read the error messages, because the error messages, even though it's like this big giant obnoxious, very hard to parse and read blob of text, it's usually telling you what's going on. And some languages are much better about telling you what actually the problem is than others. Go's decent. I think Rust is probably a little bit better. It has nice little hints and tells you like maybe you should look at this, maybe you should look at that. But Go, like it's pretty good. It's not too obscure. So here it's telling us, look, in the Blackjack program, on blackjack.go on line 10, character 21. Whoa, there's a syntax error. Unexpected new line, expecting a colon. So the compiler got to the end of the line. It was expecting a colon, but instead it found a new line. So instead of finding a colon, it found that I had just hit enter. So if we go to line 10, this is line 10 right here, is case 3. And sure enough, instead of having a colon here, I have an enter. So I'm just going to fix that, put a colon there, put a colon here. And I did the problem all the way down the line. So let's put a colon everywhere where we missed one after every case. And I think after the default one, you also need a colon. So hopefully that will work now. Let's try again. Run tests. Okay, error, invalid operation, invalid operator, or not defined on 10, untyped string constant. Okay, so apparently you can't do or like this on an untyped string constant. So I know I can compare. Okay, so I'm doing something weird with my comparison here. You can't compare, you can't or strings like this, I guess, is what that's telling me. Maybe there was a hint up here on how to do it right. Otherwise, I can just split those out again and do the long way. Um, yeah, for now, I'm just going to do that the long way. I'm sure there's a way to, yeah, here we go. So here, case age risk greater than 20, age less than 30. Okay, so maybe I need to actually put, I didn't think I would need to since I'm switching on card. And this is a slightly different example. Right here is just a bare switch without specifying a variable. But I think I can still do if, let's see, I think I can still do this. Let's try this and see what happens. Card equals 10. I'm not sure this is going to work. We're just going to try it. Card equals jack, or card equals queen, or card equals king. I just assumed it would implicitly compare that against card, but I guess maybe that assumption was just not the case. So let's see if that works. No, does not like that either. Cannot convert card equals 10 or card equals jack or card equals queen or card equals king untyped Boolean value to string. Okay, so I'm guaranteed there's a way to do what I'm trying to do here. I just don't know off the top of my head what it is. So let's just convert these to what we were doing before, even though it's going to look silly. Case, so we'll just do 10. Again, like we were doing before. Return 10. Case jack. Return. And then the same thing here. Oh, I'm forgetting again my colons. Return 10. case queen, return 10. And when we look at other people's solutions, you're going to see that like this was not the best way to do this, but that's fine. It's going to solve the problem. Case king, return 10. Okay, so we got now 10, jack, queen, king, returning 10, and I got the colons there. Default 0. All right, let's try that again. I was trying to avoid that, but that's all right. Like I said, I'm a little bit rusty. One test failed. Okay, so 14 tests passed. Cool. That's awesome. So we just passed like 13 more tests than we passed a second ago. Then, uh, oh yeah, you're right. Someone's pointing out that you can just list the cases consecutively without having a return. And that's a very good point, and I totally forgot about that. So that would look like this. So from case 10, instead of returning 10 here, I think we'll do, we'll get rid of that return, and we'll say case 10, case jack, case queen, case king. We'll all return 10. I totally forgot you could do that. I think that you are right. So let's try that real quick because that's a little bit cleaner. Not a million times cleaner, but it's much cleaner than what I had. So yeah, I think that should work. Let's try that. Thank you, R Primus. Missing return. Where am I missing? What did I do wrong? Case. Line 32, missing a return. Okay, what did I do wrong here now? Missing return. Okay, well, I did something wrong, but I'm not sure what. It thinks I'm missing a return down here. Maybe. I'm not sure why that I'm missing a return there, but it worked before. But okay, let's see if we can fix that with that. Cool. I have less test passing now, but that's all right. I must have introduced an error when I switched that 10 jack queen king. Something I did caused another error. Unfortunately, I don't have time to dig into it because I have to go to work. But yeah, thank you everybody for hopping on and watching the stream. Didn't quite get to finish the blackjack one, but we have one more function we could implement here. And the nice thing here is that my work is saved, so I can come back to this later and keep going from where I left off. I have 11 tests passing, I think. 4 tests that I still need to fix, and then we'll be able to submit this exercise also and see how other people solve the problem. So that's it for me. Thanks a lot for showing up, and thanks for watching. Now I have to figure out how to stop streaming. Stop sharing the screen. Somewhere here I can end. I never titled this recording. That's all right. Just put my name. And I think I need to go stop. Here we go. All right, I'm stopping the stream. Thanks, everybody. Have a good day.